All right, so this next part that we're going to be looking at is adding and subtracting polynomials. Now, before we get into adding and subtracting polynomials, we need to really talk about combining like terms, okay? Now, when we're talking about combining like terms, combining can mean adding and subtracting, putting two terms together. And terms talking about, like we looked at with polynomials, really we're saying we're taking those monomials, those single terms, and we're combining them that go with their like term, okay? Now, there's two parts that are required to be a like term. One, they have to have the same variable, okay, or variables or lack thereof, okay, but to be simplified for what we're doing, we're just going to say variable, and then same exponent, okay. So for instance, let's just write out a couple of examples. Well, I'll let you write this down real quick and I'll write it out to the side. So for instance, let's say I had 4x plus 5x, and I had 4x squared plus 5x. Let's say I had 4x plus 5y, and then let's say I had 4x plus 5, okay? So looking at these guys, we want to decide what works and what doesn't work, okay? So looking at these guys in the first one, 4x plus 5x, would those be considered like terms based on our definition? Well, yeah, they have the same variable of x, okay? They have the same variable of x, and they both have an exponent of 1, even though we don't see it. So we could combine those two together, 4x plus 5x, and together that would give us a total of, together that would give us a total of 9x's, okay? So that would equal 9x's, okay? I couldn't write it above, but so we can put 4x's together and 5x's together to make 9x, okay? What about 4x squared and 5x? Would that work? Well, they have the same variable. However, what's the problem? One has an exponent of 2 and one has an exponent of 1. So that does not work, okay? This guy does not work. Maybe we can just sketch a line through it. That doesn't work, okay? What about the third one, 4x plus 5y? Well, no, because they don't have the same variable, right? One has an x and one has a y. So that guy doesn't work either. What about 4x plus 5? Well, no, one has a variable and one's just a constant. That doesn't work either. So that's the key, guys. On this top example, that's a good example of what works. 4x plus 5x, they both have a variable of x, and both x's have an exponent of 1. Okay, so they have to have like terms. So with that in mind, let's look at a couple of examples here with adding and subtracting, okay? So let's look at number 1 and then number 3 here. This is addition, and what it's saying is we want to take this polynomial and add it to this polynomial, okay? Now, when we're talking about addition, notice there's nothing happening around the parentheses. All the parentheses is really doing here is telling us which two polynomials are added together, but it doesn't really serve a purpose when we're trying to combine like terms. So we're just going to drop the parentheses. We're just going to drop the parentheses and rewrite what we have. Okay, then what we're looking for is to combine like terms and put it in standard form. Remember, highest exponent to lowest exponent, okay? So the way I would approach this is look for the greatest exponent first. In this case, 7b cubed, 3 is the greatest exponent, and then see if you can combine it with another b cubed. Well, no, it's the only one, so we're going to list it as the first term in our polynomial, okay? And then we can cross it off our list. Well, then we're going to look to combine the next highest exponent. Notice there's a b squared and a b squared. 2 is the next highest exponent. Well, those guys are like terms. They both have a variable of b, and they both have an exponent of 2, so I can combine them together. So 7 plus 3 gives me 10. So both of those can combine to make 10. Then lastly, we have negative 6b and negative 6b. That would be the next highest exponent. They both have a b with an exponent of 1. Negative 6 minus 6 is negative 12b. Okay, so both of those combine to make negative 12b. And that would be our answer in standard form. Let's try one more addition here on number 3, and we can do number 2 together in class, and then we'll look at subtraction. So again, with addition, we don't really need the parentheses here. We can just kind of drop the parentheses for now and just focus on the combining like terms. okay? So again, let's look for the highest exponent. The highest exponent I see here is an exponent of 4, and there's no other one, so I'm going to list that term first and keep the sign. That's important. It's a negative term, so we're going to keep the sign. Then the next highest exponent I see are exponents of 3. So we have a negative 4x cubed and a positive 5x cubed. We can put that together. Negative 4 plus 5 is positive 1, or you could just say plus x cubed. Okay. Then the next highest exponent I see is the x squareds. So we have a 2x squared and a 2x squared, which makes 4x squared. Then the next highest one I see are the x's. 2 plus 5 is 7x. And then the last one I see is the 7, and there's nothing to combine it with, so it's just plus 7. Okay? So this would be our answer simplified. Okay? Now that's addition. The next thing we would look at is subtraction, and with subtraction, there's just one step that we need to add to this, okay? What you need to understand with subtraction is we're saying we're taking this polynomial and this polynomial, but we're subtracting one from the other. We're taking this whole thing away from this guy, okay? That changes things just a little bit because now the parentheses is important with that negative sign. What we're going to do is treat this like it's a negative 1 in front, and then distribute that negative to each term first, okay? We're always going to do this when it comes to subtraction. We're going to distribute the negative, so it's going to change the signs. A negative times a 4b squared makes a negative 4b squared. A negative times a 7b makes a negative 7b, okay? So that's always step number 1 when subtracting. But the first polynomial doesn't change because that's not being subtracted, it's what you're subtracting from, okay? So now, combining like terms, the greatest exponent I see is the b squareds. But what happens when you have a 4 minus a 4? It's a 0, right? So basically they just cancel out and we don't need to put 0. And then the next one I see is a 5b minus 7b. 5 minus 7 is a negative 2b. And then all we have left is plus 1. Okay? So that would be our answer. Well, let's try one more. We can do number 6. So again, the first thing we're going to do with subtraction is treat it like we have a negative 1, or you could just treat it like a negative and distribute that negative to each term, okay? So a negative times a positive gives me a negative 6k squared. A negative times a negative makes a positive 6k. A negative times a positive makes a negative 3k cubed, or to the 4th power, excuse me. A negative times a positive makes a negative 2k cubed, okay? So that's step number 1. And then we're going to go back and rewrite the first one just as it is. Okay, no changes, just as it is. Okay, so now we can combine like terms just like we do with addition. The highest exponent I see are the exponents of 4. So negative 5 minus 3 is a negative 8k to the 4th power. The next highest one I see are the cubes, okay? And really this is a negative 1, so we'd have a negative 1 minus 2 is a negative 3k cubed, okay? And then the next highest power are my k squareds, and again this is like a 1, so 1 minus 6 is a negative 5k squared. And then we have k, just 1k plus 6k, and then we have our constant, which is 5, okay? So this would be our answer simplified.